Good morning, students. Last class we discussed algorithm specification and performance analysis. Okay. Now we go for the divide and conquer technique. See, in the general method, given a function to compute on n inputs, the divide and conquer strategy suggests splitting the inputs into k distinct subsets. That is, 1 less than k less than or equal to n yielding k subproblems. Simply we can divide and to perform the operations. These subproblems must be solved and then a method must be found to combine sub-solutions into solution to the whole. If the subproblem are still relatively large, then divide and conquer strategy can also possibly be applied. So first of all, we have to apply the divide and conquer when we have to split the n inputs, and also it will be launched. Then we can also go for the reapplied. Okay, so if subproblems are still relatively large, then divide and conquer strategy can possibly be reapplied. Okay. So these subproblems resulting from a divide and conquer design are of the same type of original problem. So for those cases, the reapplication of the divide and conquer principle is naturally expressed by recursive algorithm. Okay, so the technique is divided into three steps. First one is the divide and conquer and combine. That is, divide the problem into the number of subproblems. Find the solution for each subproblem. Combine the solution of subproblems into a solution of original problems. So the technique is divided into three steps. That is the divide, conquer and combine. So divide and find the solution and combine these subproblems, then get the original problem. Okay, so divide the problem into number of subproblems, find the solution of each subproblem and combine the solution of subproblems into a solution of a original problem. See here, we go for the control abstraction. Divide the conquer strategy is as follows. That is, a control abstraction is a procedure whose follow the control is whose the primary operations are specified to the other processes. Here is the control abstraction, that is the process. See here, algorithm divide and conquer of particular problem, that is algorithm D and C, that is divide and conquer of a particular problem. That is, if small of p, that is the problem given is small, then return the problem of the particular solution. Otherwise, that is else, divide p into smaller instances. That is, the problem will be divided into the small instances. That is p1 comma p2 and so on pk comma k greater than or equal to 1, and apply d and c divide and conquer to each of these subproblems and return to combine of d and c of p1, d and c of p2 and d and so on c of p comma p of k. Okay, so first of all we go for the control abstraction of divide and conquer is algorithm d and c of p. That is, if small of p, then return particular problem. Otherwise, the problem will be smaller instances divided into the smaller instances and apply the divide and conquer technique and combine the all the subproblems and get the original solution. So it is called as a control abstraction. Okay, it is the procedure whose fall of control is clear to the but whose primary operations are the specified to the other processors. Okay, consider the p is a problem to the here. So here p is a the given problem. So algorithm d and c of p, and if the problem is given small, so we have to return. Otherwise, the p will be divided into the smaller instances and apply to the d and c. Then we have to produce to the problem. Okay. See here, d and c of algorithm, the problem is initially invoked as d and c of p, where p is the problem to be solved. So small of p is a Boolean value function that determines whether the input size is small enough that the answer can be computed without splittings. Okay. Otherwise, the problem p is divided into smaller subproblems such as p1 comma p2 and so on pk. Okay. So small of p is a Boolean valued function that determines whether the input size is small enough that the answer can be computed without splitting. If the given problem is small, without splitting we can compute it. Otherwise, the problem will be divided into the smaller subproblems, that is the p1 comma p2 and so on pk. So combine is a function that determines the solution to P using the solutions to the K subproblems. That is, if the size of P is an N and the size of K subproblems are N1, N2 and so on Nk respectively, then the computing time of D and C is described by the recurrence relation, that is T of n equal to G of n, that is n small, otherwise T of n1 plus T of n2 plus and so on T of nk plus f of n otherwise. Here T of n is the time for D and C on any input of size n, and G of n is the time of compute the answer directly for small inputs, and f of n is the time for dividing P and combining the solution to the subproblems. Then the complexity of many divide and conquer algorithms is given by the recursive form, that is T of n equal to T of 1, that n equal to 1, and a into T of n by b plus f of n is n greater than or equal n greater than 1. Here a and b are the constant values. We assume that T of n is known and n is the power of b, that is n equal to b power k. One of the methods for solving any such recurrence relations is called substitution method. So it is called as a substitution method. This method repeatedly makes substitution for each occurrence of the function. Then t is the right hand side until all such occurrences appear. See, we can use the one of the method for solving any such recurrence relation is called substitution method. This method repeatedly makes substitutions for each occurrence of the function. So t is the right hand side until all such occurrences are disappear. See, for example, consider the case in which a equal to b equal to, let t of n equal to 2 and f of n equal to n. We have t of n equal to 2 t of n by 2 plus n, and also 2 into t of n. Here this is t of n equal to this function 2t of n by 2, then 2 of t of n by 2 is t of n by 2 by 2 plus n by 2. So likewise 2 cube into t of n by 2 power n plus 3n. Here you can use the n power I, that equal to 2 power I of t of n by 2 power I plus in. Then 2 power I you can take as the n value, then we can apply the both of log, then we can get the n equal to, that is 2n plus n log n base 2, that equal to t of n equal to big O of n log n. So it is the complexity of big O of n log n. Okay. So 8, that is equal to 2 cube into t n by 2 cube plus 3n, that is the 3 equal to I, that is the 2 power I n by 2 power I plus in. Okay, here we can apply the 2 power I equal to n, then we can apply the both side of log, that is log 2 power I equal to log n, then I equal to log n base 2. Okay, it will be substitute with the particular condition, then we can get the t of n equal to big O of n log n. Okay, we can get the big O of n log n. Here we can use the substitution method. See here, one of the method for solving any such recurrence relation is called the substitution method. This method repeatedly makes substitution for each occurrence of the particular function. So capital T is the right hand side until all such occurrences are disappear. See here, so a equal to b equal to 2, let t of 1 equal to, then f of n equal to n. We can get the t of n equal to big O of n log n. Okay, here you can apply 2 cube n by 2 cube plus 3n, that is equal to I equal to n, that equal to 2 power I equal to n, then log 2 power I equal to log n, when then n equal to log, so then I equal to log n base 2, then we can substitute this function, then we can get the big O of n log n. Okay, then go for the binary search. So binary search is a technique, is search method to determine whether the given element present in a list or not. See here, let small a be a list of elements that are sorted in ascending order. Consider the problem of determining whether a given element x is present in the list or not. If x is present, we are determining a value j such that aj equal to x. If x is not in the list, then j is said to be 0. Okay. See, let p equal to n comma ai and so on aj comma x denote an arbitrary instance of this such problem. Here n is the number of elements in the list ay comma and so on al is the list of elements and x is the element for search for the particular given the list. If p has more than one element, it can be divided into the new subproblems as follows. That is, pick an index q is a range I comma 1 and compare x with aq. There are three possibilities. If x equal to aq, the problem is immediately solved. If x less than aq, x has to be searched for only in the sublist, that is called ai comma ai plus 1 comma ai plus 2 and so on aq1. If x greater than aq, the sublist to be searched is aq plus 1 and so on l. Okay. After comparison with AQ, the instance remaining to be solved by using divide and conquer scheme again. If Q is the chosen such that AQ is the middle element, that equal to Q equal to n plus 1 by 2 or Q equal to low plus high by 2 or I plus 1 by 2. Using this condition, Q equal to low plus high by 2. Okay. See, this is an algorithm binary search of a comma I comma l comma x. That is, given an array a of I is the elements in non-decreasing order and order 1 less than I less than or equal to l, determine whether x is a present, and if so, return j such that x equal to e of j, else return 0. So how you can calculate? See, if L equal to I, then that is if small, then if X equal to E of I, then return I. So the given element is small, we can return, else return 0, that is mid equal to I plus L by 2. Then if X equal to E of mid, then return mid, else if X less than E of mid, then return binary search of A comma I comma mid minus 1 comma X. Then else return binary search of A comma mid plus 1 comma L comma X. If the given element is small, like we can then produce the X equal to A of I. Otherwise, we can reduce P into smaller subproblems. We can go for the mid equal to I plus L by 2, or otherwise A plus B by 2. Okay. If X equal to A of mid, then return the mid value. Otherwise, if X less than A of mid, we can check, or X greater than or equal to mid, we can search A comma mid plus 1 comma L comma X. So likewise, we have to search the binary value. So the given list of elements, the such element will be present or not. Okay. So this is an algorithm. That is algorithm binary search of if L equal to I, then if X equal if X equal to A of I, then return. Otherwise, it P reduce P into a smaller subproblem. That is, you can go for the mid equal to I plus L by 2. Then if X equal to A of mid, then return mid. Otherwise, else if X less than A mid, then return binary search of A comma I comma mid minus 1 comma X. Else return binary search A comma mid plus 1 comma L comma X. Okay. See here. Algorithm binary search A comma n comma X, low equal to 1, high equal to n, while low less than or equal to high, then go for mid equal to low plus high by 2. If X less than A, high equal to mid minus 1, X greater than A, low equal to mid plus 1, else return mid value. So likewise, we have to construct the binary search. So binary search are using to search the given list of elements will be present or not. See here whether the X is present or not. If X is present, we can return. Otherwise, we can search the elements from the given list of the elements. Okay. See here. Let us select the 14 entries, that is of minus 15, minus 6, 0, something like 7, 9, 23, 54, 82, 101, 112, 125, 131, likewise. Okay. Place them in E of 1 is to 4, 14 and simulate the steps. Binary search goes through, it searches for different values of X. So only the variables low, high and mid needed to be traced as we simulate the algorithm. So we try the following values for X equal to 151 comma minus 14 and 9. So for example, X equal to 151, so low value, high value, the mid equal to 7, low value, high value, that equal to 11, and low value 12 and high value 14 and 14 and 14 equal to 14. So we can find the value in x equal to 14, but it will not be present in the list. So in that way we can assign is not found. X equal to 9, it will be list of the found. See here, 1 2 3 4 5. So fifth element is 9 and 14th element is 151. If there is no 14, so likewise here, so 14 element is found, and if there is no element and 9 is the fifth element, so found. We found the fifth element. So likewise we have to search the, we have to trace the binary search of the different type of steps. Okay, this is a table of shows the trace of bin search on these three steps. Okay, x equal to 151, x equal to minus 14, x equal to 9. The next one, maximum and minimum. So let us consider another simple problem that can be solved by the divide and conquer technique. The problem is to find the maximum and minimum items in a set of n elements. See, in analyzing the time complexity of algorithm, we once again concentrate on the number of elements of comparison. Here you can calculate which is the maximum element, which is the minimum element of the given elements. Okay, so here you can consider another simple problem that can be solved by the divide and conquer technique. So the problem is find the maximum and minimum items in a set of n elements. In analyzing the time complexity of this algorithm, we once again concentrate on the number of element comparisons. Okay. More importantly, when the elements in A of 1 is to n are polynomials, vectors, very large numbers, or strings of characters, the cost of an element comparison is much higher than the cost of the other operations. Hence, the time is determined mainly by the total cost of the element comparisons. So, see, algorithms type max and min of a comma n comma max comma min. Set max to the maximum, min to the minimum value of a of 1 is to n. See, if max equal to min equal to a of n, that is only single element, it's okay. Otherwise, for I equal to 2, n do. For a of I greater than max, then max equal to a of I. If a of I less than min, then min equal to a of I. So likewise, we have to write an algorithm. So if only single element, for max equal to min equal to a of 1, otherwise we go for I equal to 2 to n. Then if you a of I greater than max, then max equal to a of I. If a of I less than min, then min equal to a of I. Okay. So straight max and min requires 2 into n minus 1 element comparisons in the best and average and worst cases. Okay. So what is the best case and average case and worst case? In best case, the minimum number of steps will be required. Average case is the average number of steps will be required, and worst case, the maximum number of steps is required to complete the particular problem. An immediate improvement is possible by realizing that the comparison a of I less than min is necessary only when a of I greater than max is false. Okay, see, a divide and conquer algorithm for this problem would proceed as follows. See, let P of n comma a of 1 and so on a of j denote an arbitrary instance of the problem. Here n is the number of elements in the list a of I and so on a of j, and we are interested in finding the maximum and minimum of the list. If the list has more than 2 elements, P has to be divided into smaller instances. So for example, we might divide the P into 2 instances, that is P of 1, that is n by 2 comma a of 1 and so on a of n by 2, and the next one n minus n by 2 comma a of n by 2 plus 1 and so on a of n. So the P will be divided into the 2 type smaller instances, that is 2 instances, that is 1 to a of n, then n minus n by 2 comma a of 1 and so on a of n by 2, and n minus n by 2 comma a of n by 2 plus 1 and so on a of n. So after having divided P into 2 smaller subproblems, we can solve them by recursively invoking the same divide and conquer algorithms. Okay, we can use the different type of procedures. Okay. C is the algorithm of max min, that is algorithm max min of I comma j comma max comma min. See, if I equal to j, then max equal to min equal to a of I, where if the small of p Otherwise, that is another case of small of p, then else if I equal to j minus 1, then if a of I less than a of j, that is max equal to a of j, then min equal to a of I. Otherwise, max equal to a of I and min equal to a of j. See, if p is not small, then p is divided into the smaller subproblems, that is mid equal to I plus j by 2 and max min of I comma mid comma max comma min, then max min of mid plus 1 comma j comma max 1 comma min 1. Then combine these solutions, that is if max less than max 1, then max equal to max 1. If min greater than min 1, then min equal to min 1. So likewise, we have to construct the which is the maximum value, which is the minimum value. If small is p is one of the condition. If another condition is I equal to j minus 1. If p is not small, then we go for divided into the sub problem, that is mid equal to I plus j by 2 and max min of I comma mid comma max min. And whenever it will be completed, then we go for combine the solution, that it compared to the another max value, that is if max less than max 1, then max equal to max 1, then if min greater than min 1, then min equal to min 1. So likewise, we have to calculate the max and min values using the divide and conquer strategy. Okay. See, the procedure is initially invoked by the statement max min of 1 comma n comma x comma y. Suppose we simulate max min on the following 9 elements. See, for example, 22, 13, minus 5, minus 8, 15, 60, 17, 31, 47. For this algorithm, each node has 4 items of information L comma j, that is max and min. So for example, we see that the root node contains 1 and 9 as the value of L and j, corresponding to the initial call to the max and min value, which is the maximum, which is the minimum value. This execution produces the two new calls to the max min, where L and j have the I and j have the values 1 comma 5 and 6 comma 9 respectively. This split the set off into two subsets of approximately the same size. From the tree, we can immediately see the maximum depth of recursion is 4, that is the first call, and the include the number of numbers in the upper left corner of each node represent the order in which max and min are assigned to the different values. And number of comparison, so see, t of n equal to t of n by 2 plus t of n by 2 plus 2 if n greater than 2. If n equal to 2 is 1 and n equal to 1, it is 0. When n is the power of 2, n equal to 2 power k for some positive integers, then k, then t of n equal to 2t of n by 2 plus 2, that equal to 2 into 2t of n by 4 plus 2, okay, that is 4t of 4 by n by 4 plus 4 plus 2, that is, and so on. 2 power k minus 1 t of 2 plus sigma 1 less than or equal to I less than or equal to k minus 1 into 2 power I, that is 2 power k minus 1 plus 2 power k minus t equal to 3 n by 2 minus 2. Okay, it is the one of the conditions. So here you can, now we can search the what is the divide and conquer strategy, and what is the binary search, what is the maximum and minimum values. Okay, so what is the meaning of divide and conquer strategies? We can divide and conquer and sub to the problems. Okay, first of all, if the given problem is big, we can divide into the different type of instances. Whenever we have to divide the different type of instances, that instance also is big, then we go for the reapplied. Okay, then when we have to complete it, then we can combine to the all the sub problems. Okay, so in that way, you have to assign 3, that is the divide. See here, divide, conquer and combine, that is divide the problem into number of sub problems, find the solution for each sub problem, and combine the solutions of the sub problems into a solution of a original problem. So these 3 steps is the in divide and conquer technique. Okay, so divide, conquer and combine. Okay, so it is the control abstraction. This is the algorithm for control abstraction, that is algorithm D and C, that is a divide and conquer of particular problem. Is small of p, then return the particular problem. Otherwise, that problem will be divided into the smaller instances, that is the p1, p2 and so on, pk. Okay, and apply D and C of each sub problem, then return combine to the D and C of p1 and D and C of p2 and D and C of PK. It is also called as a control abstraction. Okay. So control abstraction is the procedure whose follow the control abstractions whose primary operations are specified by to the other process. Okay, it is the most important with the number of times it will be asked from the question papers. Okay, and go for the time complexity, like calculate the time complexity and go for the binary search. And next one is the maximum and minimum. Okay. Thank you.